Hi everyone, and welcome to lesson 12.1. Today we are going to start talking about a different kind of proof beside our two-column proof. And you're going to want to use the notes handout provided in Google Classroom, and you may also, or you're going to want a notebook to take notes in, since these are not coming from your book. So today we are going to start with talking about the proofs that we know how to do, which are our two-column proofs. So when we have a two-column proof, we always start by writing down the given information and marking it in our picture. So they have the first given written in is that DB bisects segment AC. And we know that when that segment is getting bisected, that means that segment AB is congruent to segment BC, because that's what the definition of bisects means, right? We're going to use that given information to find our first piece that's congruent. And then they also gave us up here that DA is congruent to DC. So we can also write that in our proof because that was also given to us. Now, the next piece of information we need to assume from the picture, because we need a third piece of information to prove triangles congruent. And in this case, that's going to be that segment DB is congruent to itself because of the reflexive property, right? Something is congruent to itself by the reflexive property. And now we have three pieces of congruent pieces in our triangles: a pair of sides, another pair of sides, and another pair of sides. So these triangles are congruent by side, side, side. Now, we can also write this as a flowchart proof, which is what the lesson here is all about. With our flowchart proofs, we can organize this the same way, where this first piece was given to us. And then from there, we decided that AB is congruent to BC based on the definition of bisects. And then we also wrote down the next piece of given information. And finally, we used the reflexive property. So we see here then that flows into our proof statement that we said was possible by side, side, side. So your statements go inside the box and the reason goes below it. It makes sense that we have these boxes the way they flow as well, because we needed to flow from this box to conclude this piece here with AB being congruent to BC. And then we needed all three pieces of information to conclude that our triangle was congruent. So that's what the next page talks about here. Why does it make sense that there are three arrows when we are talking about pointing inside this box? Well, it makes sense that there are three arrows because we need three congruent pieces of information to prove triangles congruent. And using our four methods, no matter which one we use, we need the three pieces of information. So again, that's a nice way to check yourself to make sure that things flow to the right location. Okay. So we have another example here. And when we look at this next proof, it's kind of that same idea. We're going to start here with B being the midpoint of AC. So from there, we know if B is the midpoint of AC, we can conclude that CB is congruent to AB because of the definition of a midpoint. Now, beyond that, we also were given, besides that DA is congruent to DC. And we know that was also given to us. So that was filled in. Finally, we again need to conclude a third piece that is congruent. So that's where the reflexive property can help us again, because we have DB congruent to itself inside there. And finally, these triangles are also congruent by side, side, side. Now, once we conclude that the triangles are congruent, we can conclude that the angles are also going to be congruent, because we know that in a congruency statement in the triangles, we know that angle DBA, or we know that angle CDB and angle ADB are going to line up because of the congruency statement, and we would use CPCTC to conclude that. Okay. Let's try one more example together here, and we have another problem here that filled in the first piece of given information for us. Now, from that piece of given information, we are able to conclude from that if C is the midpoint of segment AE, AC has to be congruent to CE because of the definition of a midpoint. Midpoint. Now, from there, if we read the next bit, that's our second given. Angle A is congruent to angle E because that was our other piece of given information. So we need to then use that in our proof. And again, make sure you're always marking your picture. Now, finally, we have to conclude a third piece of information congruent. And this time we don't have reflexive sides like the first two examples. This time we have a pair of vertical angles. Now, making sure we name this correctly, instead of just saying angle C and angle C, we could say angle ACB is congruent to angle ECD, right? Because we know that vertical angles are congruent. So finally, we have our three pieces of information filled in, and we can conclude our triangles are congruent, this time by angle, side in the middle, angle, and ultimately prove that segment AB is congruent to segment ED because of CPCTC. Okay. We have one more example down below here. I'm going to give you guys a moment to try this out. We'll call this box number 1 and its reason, box number 2 statement and reason, 3, 4, and 5. What do you think needs to go in? Well, inside box number 1, we're going to start by writing down the first bit of given information. And in box number 2, we are also going to write down the second bit of given information. Now, very important to make sure that we also mark this in our picture. Okay, so we have MO and PO congruent, and then MON and PON congruent. Now from here, what we're going to do is we are going to look at the last piece that we can assume from the picture, and that's going to be that our reflexive side is congruent to itself. And again, we know that that is true because of the reflexive property. And ultimately, we can conclude that these two triangles are congruent to each other because we have two different sides and then the angle in the middle. So side, angle, side would be our reasoning to finally say our final proof statement here, that the angles would then be congruent because they are corresponding to each other in congruent triangles. So CPCTC. All right, we will practice more with this in class. Thanks, everyone.